Okay, I think we are live. Let me adjust a little bit. Okay, sounds good. Sounds okay. That's good to me. LTTM. SCTM. No. What am I doing? Okay, yeah. Need to go here, here, here. And then I gotta do this. Okay, so what am I doing today? Let's call it part 2. I can remove the side mission now, because day 2, second day of progress. Feeling optimistic about today. So I've got to be a little bit quiet because my friend is mosquito. My friend is staying, so don't wanna wake her up. But I sound pretty loud even when I speak quietly. That's pretty cool. Nice. Hang on. Okay. Sounds good. Yeah. Oh, I gotta pop this out. Then I'll just move it here. And then, okay. Bitrate's looking good. Let me just check. Yeah. Upgraded my Wi-Fi, so in a couple of days it should be better. Okay, so let's get back. You know what? I do miss music. It's like if I press the space bar, I get banned. Okay, copyrighted. Okay, not gonna do that. In fact, let me just close this. Don't want to have any accidents. Okay, where was I? I just turned over in my bed yesterday when I woke up, so that's why I wasn't here. I would say I was a little bit mad at myself. I wasn't even sleepy because I woke up like a couple of hours later. Anywho, moving on. So, excuse me. For today, right, okay. I think I read the I read the entire intro. For UART. I'll leave this open because it was quite useful. Then, oops, yeah. Okay. And I did leave a note to myself. Chapter 11. Yeah, I remember that one. That bit. Okay. Okay. I didn't sleep quite a lot last night. I can feel it now. Feeling a bit hazy. Okay. Okay, let's get on with it. Okay, there's two groups of UART interfaces. 0 and this one. The headers on mine are already sorted. So okay. CPIO2. Think. Hang on. Okay. Let's have a look. Jeez. IO2. Yeah, see it. I see it. What about the other ones? TX, RX, CK. Not sure. I believe the mic catches it. No. Catches it sometimes. Strange. Okay, the basic working process is of transmission FIFO. As long as there has data filing into transmission FIFO, it'll immediately start sending process. I think there's some missing words here. As long as there has data filling into transmission FIFO, first in, first out, transmission. Not sure I understand this sentence. Okay, I'll read on. Since transmission itself is relatively slow process, other data can be sent to the transmission FIFO simultaneously. Data sending should be paused when the transmission FIFO is full. Okay. What is transmission FIFO? Is that the data structure? That'd be my guess. Jeez, I look a bit sleepy. Okay. I'm gonna try and look alive. Right, okay. Transmission FIFO. What? Excuse me. Is there something I'm missing? Okay, so why don't you just call it a buffer? What's with the order of data? Yeah, because otherwise you lose data. Okay, then you gotta wait till the entire buffer is empty. Data has been sent will be automatically clear. At the same time, there'll be more of a vacancy. The basic working process of receiver FIFO. When the hardware logic receives the data, it will fill them into receiver FIFO. Program should withdraw the data timely. Yeah, okay. It's kind of like, no, it's not. I thought it's like an unbuffered channel. No, because it's not, it doesn't block. Data DQ is also a process of deleting data from FIFO automatically. Thus, there will be one more vacancy in receiver FIFO. The data in the receiver cannot be removed in time, will be full, which makes data loss. Oh, so it just keeps sending it. Interesting. Scenario. Okay, I like good scenario. UART 0 works as data communication and UART1 works as debug port. Too far from debugging. Okay. What is this? RTS, ground, UART 0. What is it called? VGA cable? Yeah. How many pins does it have? Images. Got about, okay, it's 3 layers. It's quite a lot. It looks like VGA. Could be wrong. I think it is, because it's got those screws. Okay, okay. I have no idea what I'm looking at. Is it like before it went onto the PCB? This is what it looks like. That's probe. Oh no, but there's fucking 3 of them. What's with like all these cables? TTL converter. You know, I have a feeling I'm going down the wrong path. Yeah. Okay, let me read this chapter and then I'll know more. Yuatsuro will default output some print while booting. Jeez. This is some crazy translation. UR0 will default output some print while booting. Okay. There'll be some default stuff printed. And the baud rate's gonna be the external crystal frequency. I don't know what crystal this is. Oh, I could just... Why am I being so silly? ESP01S crystal. Crystal. Is that even a good, the right question? Look, they usually have... Okay, they seem very excited. Oh, it comes pre-programmed. I feel even more stupid now. Ah, I see it now. Then it's 26,000. That is the crystal. I don't know what it does, but I know that's the crystal. Could be very well be wrong. Should have probably read this before. From another application processor each. Yeah. Meaning you can... Offers and just out of the box. Okay. It's pre-programmed. You still need to read data from it. How are you supposed to do that? Let's have a look at this firmware. AT instruction, hardware matching guide. This is instructables. Yeah. Jeez, some crazy wiring here. Yeah. Yeah, I've got it hooked up. Done. I've written the following basic terminal program for Micromite. What is this program doing? Guessing these are variables of some sort. A is the input, like a scanf. Okay, if A is, I'm guessing, not empty, then if look of 1, I'm guessing the second argument, I'm just guessing here, like, what's it called? Yeah, like in C. Then B is the second argument. Is that correct? Not sure. Something. Go to terminal. Okay. Just keep going back for some reason. For your wireless network, you should already know your SSID and password. Oh, so you're writing the command. Hang on. ASCII table. Decimal 31. What's 31? It's a symbol. What is 11? It's also a symbol. What is the symbol? Why is it HTML? Not sure. Okay, let's have a look. Yeah. Let's type AT plus RST. Give the module a moment to reset. See a paragraph of data returned. Really? But I'm not sure where am I writing this. Oh, to the UART. So I don't need to prepare the data like so. Interesting. Type AT plus some mode. Set both as a client and access point. Interesting. Type the following command, replacing SSID and password with your information. Okay. Now we need to see the IP it has been assigned to. Okay. Lost about half our audience at the end of the last step. Ah, okay. But need some guidance in the world of networking. Yes, sir. Don't worry, you're in good hands. Okay, not worried anymore. I'm going to condense a semester of networking class into just enough networking knowledge to be really dangerous. Oh, I like dangerous. Let's go. So, yeah, I do. Oh, well, I don't. Should probably get till here. Okay, hang on. What am I doing? Yeah, okay. Micro sig. Maybe there's a UART example. Yeah. Examples. SDM. Oh. Blinky. Oh no, this is the chip. I gotta look at Eco, yeah. Is that oh, that is. Damn. Well, okay. No, I was just thinking. I've been trying to solve something for the last 4 days. Only to realize it wasn't that complicated. So, read blocking. Yeah. Damn. I guess now I know. Okay. Could have said TX RX. Not sure about this one. Oh, I know. Raspberry Pi. No, Pico pin diagram. Okay. So there's 2 zeros and 2 ones. And there's another 0. This one's a bit different purple. This is the default one. Okay, so if I say u art 0 and then 17, 16 and 17. Okay. Well, to be fair though, if I hadn't gone through all the rabbit holes I did the last few days, don't think I would have understood what any of these mean. Also, even look here. Ah, so it's fine. Yeah. Part of the process. Set function SIO and dot out. LED dot put LED. Oh, this is already done. I'm inlining pin dot set function uart. What is pin again? Pin. Oh, sorry, pin's here. Okay. We set both of those to uart. I'll have a look at this. And apply the baud rate and you set the clock config. I'll check this too. Okay. And then I can send AT commands here. Hey Mikosko. It's pretty good actually. I realized a few of my mistakes. And yeah, I realized that I've got to use the UART interface to read and write something called AT commands. Where is it? Oh, somewhere here. Yeah. So some of these commands, I don't know exactly which ones. And yeah, so that's where I'm at right now. How are you doing? Okay, where am I? Okay. So I guess I'm sort of ready. Let me check the baud rate. For 26M is that. And yeah. Baud rate. That much. And what else do I need for UART? Got time? Yeah. And Damn. Worked with Intel's i686 architecture to implement thread local storage for internal project today. Damn. That sounds complicated, Mikosko. What is i686? Oh, x86. Okay. Worked with ARM previously. Yeah, never heard of i686. How did you get into like this type of programming? i383, 486, 586, 686. Okay. Yeah, that's pretty cool. Let's have a look here. It's 383, 486, 586. Okay. Guessing these are like i3, couldn't find 6. i386. Okay. What are they used for? Okay, what am I doing here? Got the clock? No, I haven't. E2040 dot clocks. Let's have a look. x86 have a long history and they are backwards compatible. Yeah, I've heard of this one. It's quite old, right? The architecture. And okay, so even the new ones still use it. We use x86 in virtual and physical network switches, proprietary protocols. Damn, your works sounds quite interesting, I have to say. Also quite complicated. And physical network switches. Ah, okay. That's cool. That's really cool. QEMU. What's QEMU? Virtual switch is basically same software as in physical, but in QEMU. Okay, yeah. Like what is? It's like a, yeah. Okay. So it's like a software representation of the physical device. I mean, that makes sense because I think it would be a lot slower to work with all the devices because you'll need a lot of them to write software for each. Okay. Right. Got the clock. What else do I need? Okay, I gotta check that. So here, instance. For your project, I'm not familiar with ESP's radio modules, but I think you will need some kind of high-speed bus, and UART won't let you operate on these speeds. Yeah, I think you're right, because I think I was reading through this document here. Use PCI Express for comms between processor and radio module. PCI Express. Oh, I've seen these. It's a high-speed serial computer expansion bus used to connect various internal components in a computer system. Yeah, I've heard of this. Yeah, so basically what I'm doing is I'm just following what they said here. But you are right, because I did notice. Hang on. Yeah, but they because I saw. Where is it? What's the baud rate that I'm using? 74,000. So I did notice like it was within this range. And yeah, I think I'll have to try and find out. If it doesn't work, I'll have to use a PCI Express. Okay. Yeah, I assumed, because it writes about 8 bits per data frame. And yeah, I think it will be slow. But I think, to be fair, I think it doesn't need to be fast, because I can do some sort of, I don't know yet, maybe on the software side I can do some form of aggregation or something, but I'm not really sure. I mean, to be fair, I haven't even got that far. I haven't even like been able to read anything from it yet, or write anything either. I can have a look actually. I think here, if I go to instance, this is it. This is the Do you want to implement everything from scratch or switch to some kind of RTOS? I don't know what an RTOS is. Yeah, I don't know if I would do everything from scratch. For instance, on this board here, apparently it comes pre-programmed. So they already have the firmware in there. So probably not gonna rewrite it, because I checked the SDK for it, and it's quite huge, and it also like does too much. It does HTTP, like protobufs, and I don't really need all of those. So yeah, probably not do the entire thing from scratch. I want to look up RTOS. Oops. RTOS. Real-time operating system. Yeah, here. Okay. I mean, it does sound interesting. Ah, okay, I see. I didn't even think that far, honestly. But if I do get to that point, I might, if it's interesting enough, just as a like a side project, I might just do it. But as of now, not really, because I wouldn't even know where to start, to be honest. Oh, and I missed the last message. Because as far as I know, implementing PCI Express is hard. Yeah, I have no idea how much work it takes to set it up. For now, my goal is like very simple. Because I think when was it? I think 2 weeks, 3 weeks. So it's only been like 3 weeks since I've started doing any embedded stuff. So for now, my goal is like very simple. Connect the ESP onto the Pico and connect it to my network, and then I just wanna do like some sort of time spent per DNS or something like that, like something very simple. Yeah, I just want to know all the DNS lookups on my network, and then use that information to show something on the display. It's super like simple, I think. And I'm trying to do like as much as I can do from scratch, because I want to understand like how it works, at least at some level. So the display driver was quite easy to write, because it's like quite small. I think the whole RAM was like, I think 512 bytes or something. So it was super easy. So you could program the entire RAM. Okay. Danny Gamer. I don't have a Discord. Danny Gamer. Yeah, I think so. Should we ban him? There is like quite a bit of spam, I would say. Okay, we'll just go on. Oh, I could have you done it here, but yeah. Yeah, no. I mean, I usually remove all the spam. Okay, so see if I can get. So I think this needs to be lower because instance. And what does instance need? Struct. Okay, it's like 0, 1. Instance of. What does it do? Enum. What is this for? It's never really used. UR driver. Note assumes proper GPIO configuration. Okay, yeah. Interrupt driven asynchronous writes/reads. That's kind of worrying. Because, no, but I think it will work because UART is asynchronous. I don't know. We'll see. Because I think, as far as I understand, it is asynchronous. Minus the interrupt. Okay, I'll have a look at it anyways. We'll try it out. Let me have a look at the example. Zero. Set the baud rate. Yeah, I gotta set the pin. Did I get GPIO? Is RP 2040? Hang on just a second. Yep. There are two ways. You may poll 100% CPU load all time, or you may handle interrupts and work with data when there is some. Okay. I mean, I think judging from the API, I might have to just poll. I think that should be okay because it doesn't really do anything else. Because it's just listening for data from the Wi-Fi device and doesn't really do anything. But I do need to aggregate. Yeah, I will probably like come back to that later when it becomes a problem. And UART transaction is, go which one it was. This one. I think I'm using these two. Is 16. Forgot how you said GPIO here. Okay. GPIO dot of how do I specify? Yeah, I think it takes U6, yeah, and it's 16. Yeah, and receive on 17. Let me just check the board. So the ESP transmits on, yeah, so it's bottom left. Bottom left is 16. Yeah, no, that can't be right. Connected this way. No. That's something looks a bit strange. Yeah, the thing is, like, on this board they have like a, I don't know, like a slot here for the ESP. I changed the breadboard because with this one I don't need a lot of wires, but this one I think they've like soldered it to 16 and 17. Oh, you mean, okay. Yeah, no, I think you're right, because it's like the GPIO pin, like these numbers are a bit different. It is pin 21 and 22. I'm just checking if it lines up correct. Yeah, it does. Okay. Oh, it's correct. Oop. What do you mean? They should all be GPIO. You mean all of these are GPIO pins? GPIO is 40 pins. There are 2 by 20. Yeah. You mean like there's 20 pins here and 20 pins here? Oh, you mean all of them are GPIO? Okay, I didn't know, because I was under the assumption that only these, they were only like 28. Okay, I didn't know I could use these pins too. That's good to know. Okay, so I've set those, and what do I need to do next? Set, go to set the, now let me see, oh, this no, let me get main here, probably, excuse me, sorry. So what I'm gonna do is can just read and write. So I'll do an init, make it public, then it would take something, probably return the UART. Don't know what the UART type is yet. Let's leave it void for now. Expected, what am I missing? Pub func init. Net ESP ask init Wi-Fi. Let's call that. Okay, my bad. All right, and what we gotta do is set up clock to be RP clock. Nothing, specify pins. Not sure. Look at the example. Okay, go to set the pins. And then set the baud rate, yeah, correct. And set the clock config. I want to check that. UART dot apply. Do I not have UART? I do. What does it return? In apply. Okay. Oh no, there's an apply here. And takes a config. Clock config, baud rate. What's the rest? Parity. Okay, none. Flow control. What is that? CTS, RTS, blah blah blah. CTS, RTS. Not sure what that means yet. Word bits. .8. Okay, so it's gonna set 8 bits at a time, or bytes. Okay. Start bit is 1. And guessing it would set the start bit 2. Parity. Stop. Okay, so it's not using any parity. Okay, so content non-config to enable validation. Yeah. Apply runtime. Okay. So it needs Fuck, I forgot. What am I doing wrong? Dot, that's why. Dot instance of 0. I think it should be instance dot num. Then I get the UART back. Yeah. Yeah. Now it should work. Okay. It needs a config. I think I can just send, what does config take again? Okay. I can just do dot clock. What was it? Hang on. I'll save this for now. Amy Costco. Okay, yeah, sure. Thank you for your help and hanging out. You have a good one. I'll see you later. Think I can use clock. Hang on. That clock config. I think I don't need the clock. Okay. rp2040 dot clock config. Okay. And it needs baud rate. Rate is equal to okay. Does it return anything? No, it doesn't. Okay. Done that. Maybe. Okay. Now gotta write stuff into. So close this. Oops. I might need this. Don't need this anymore. Data sheet UR port. I think this is done. Operation mode, data bit. Oh yeah, okay. Leave that. Might need that for later. Okay. Think. Device. Okay. Let's have a look at the AT commands. you'll see a paragraph of data returned. Okay, so gotta check as you what. Right. Well, yeah. So I was looking at this yesterday. Type write header, transmit header, and write function. Okay, so that's good. How big does the buffer need to be? Not sure. Okay, so that means I can use the, where's the generic writer? Yeah, I can just use writer dot write. Yeah. Yeah, there we go. Okay, that could work. Okay, hang on. So do I need to read anything here? Hang on. No. If I go back to the config, parity. Oh, that's the default. Do I need to check one? Set one? Enable, disable, parity. Okay. Okay. Oh, it's quite loud. Here's a list of AT commands. Web server. Really? I can run web server here? That'd be something. Oh. Damn. Well, that'd be crazy. Running a web server on a Raspberry Pi Pico. I think it's probably been done. Web server Pico. Yeah. Not surprised. Okay. Basic AT commands. Restart the module. Okay, so oh, I forgot to set. Hang on. Why is it inlined? Good question. Why is it here? Inline for loops can be inlined. This causes the loop to be unrolled, which allows the code to do some things which only work at compile time, such as use types as first class values, the capture values and iterator value of inline loops are compile time known. Okay, that is interesting. I had no idea. You need loop to execute at con time. You have a benchmark to prove that. Oh, okay. I'm guessing it's the first reason. What is it doing? Okay, the cheap viewers are back. No thanks. And I found out that these accounts are like really new. Wonder how long it takes them to like do this. Looks like a lot of work. Right, okay, in line 4, and then I've got UART TX, comma UART RX, pin, and then pin dot, what can I do with pin? Can I set yeah pin sorry, excuse me. I'm almost out of coffee. 2040 get pads is upper, set pull, set direction, put, toggle, eat. Don't see that method. Oh, set function. Okay, here. Then it expects function So it's going to be RP 2040.uart. Yeah. Switch chip. How does it know? Oh, because that's the one I've imported. That's pretty clever, actually. Dot set function UART. Did I miss something? Can't I go in? Oh, missed. That's strange. Why won't it pin dot set function? And go here. Do get pin back. If I go set function, yeah, it expects a pin. Weird. Okay, for now, leave it. And now I want to like reset the device. For that, I gotta send this command. So if I send AT, should return me back an okay. Let's see. Let's try that. So do I write to UART again? Go right first, and then okay. So this can error. Does it return something? Find out. I blocking. Payload timeout. AT. Then I think it was clock dot duration. No. Capital D. Hang on, is it clock or time? What do you do with clock? time. Time dot duration from millisecond. From millisecond. 100 for some reason. And it does error. Transmit error. Then I can even do write. No. Thought it had a writer. Oh. Writer dot write. Let's read. Okay. Then just return the error for now. And then I want to read try dot read blocking. I'm guessing need a buffer and then timeout. Okay. What I'll do is just needs to read. Okay, that's like 2 bytes. I'll just return that. No. It needs a buffer. What did I? Probably take a buffer. Buff gonna be say 4 bytes for now. Then yeah, take buff and time dot duration millisecond to 100. Did that work? Okay. Can error. Yeah. Now, don't need this. Yeah. Here. I think I can remove this message now. Okay. I need const. What did I call it? ESP. We just rename this. ESP01S dot zig. 01S zig. Yeah. Then Oops. ESP01S is import 01s.zig. Then here, yeah, ESP01s.zig. Sorry, not zig. Init. Let's just call it init. Consistency and whatnot. I'll create for buff is 4 bytes and it's undefined. Init buff. And if there's an error, it'll set the LED on. I'll just take a slice of U8. Then line 12, just need the buff. Okay. This right line buff. Does it expect const? See what that does. Sake build. I'm expecting a lot of errors. Okay, right line. Add a literal requires address of. Oh, did I not do that? Oh yeah, sorry. Oops. Damn. I'm quite impressed. Okay, let's connect this up. Moment of truth. Okay. Gotta connect this here. Good select. Okay. I think I forgot. I think it was Pico. Yeah, I cleared my history. Let's go to Andrew's blog. Sig build, this one. I think it's firmware. Yeah. Okay. The LED turned on. I mean, there was an error. Actually, I can now print the error because I have a display. Interesting. Let me make this buffer bigger. Make it 512. Can I make it 512? No. This is 128. Yeah. And then it does error. Does this error? No. Don't know. This one feels a bit weird. Cause yeah. Okay, it's the same here. And can't GD. So it could be like any. Oops. Fuck. There you go. Still have this to do. Right blocking. Transmit error. Does it say what the error is? Oh, it times out. Should probably check that the display is working. I'll use the same buffer. Sorry. Buff equals display initiated. That's too long. Display. Okay. Yep. Right buff. And then I'm gonna clear the buff. Was it? How did I do it? 0 times 128. Okay, and then you can init. Out of coffee. So I want to know which one of these functions. Oops. Doesn't return anything, does it? No. Forgot what I was doing. There is a run button. Run. Oopsie. What did that do? Something happened. Check. Yeah, no. What does that do? Nothing. Okay, sorry. Yeah. Delete this. So yeah. How do you check what type of error it is? Documentation to the rescue. Errors. Add a set type. Now data set is like an enum. However, each header name across entire compilation gets assigned, unassigned, integer greater than 0. You are allowed to declare the same header name more than once, and if you do, it gets assigned the same integer value. The header set type default is 16. Oh, I know. Think okay, what was I thinking? Yeah. So instead of a try, what I'll do is I'll catch, and instead of void, I'll return to, hey, I'll return a byte. Return 1. I mean, it's not great. Maybe not 1. It's right. So let's call it 10. Pocket. And then I'll return 20. And I then return 0. Boom. There you go. So instead of catch, we'll do return, no, code. And if code is not equal to 0, write that, then return. What am I writing? Okay, buff equals interesting. Oh, it's a byte, so buff of 0 equal to code. Okay. So okay, so the LED should turn on if the display fails. Okay. Oh. Oh. Oh, okay. That's an easy fix for that one. Don't even need that. And this will just be display. Okay. Say build. Oh, really? Oh, when did it change to init? What's that now? Not allowed on type. Ah, fuck. Good point. So, yeah. I think it'll only... Oh, okay, it's not returning an error anymore. Okay. There you go. Really? Was it not just working just now? Which Pico tool? Okay, okay. I'll just copy it for now. Where is it? Here. Take out firmware. This one. Okay. I get display okay. Then there's just a line of junk. Why is the LED on? Interesting. White line buff. Put. Do I turn it on anywhere else? No. Why? I'm doing something silly. So I call right line. Yeah, this is all like new. I think it's here. I can't send a number. Has to be tell you what. It's quite nasty. I'll send this. Nah. Excuse me. It's quite bad. Okay. Okay, got it. Actually, I don't even need this. What I'll do is if code, let's keep it simple. It's 10. I will write, oops, and then return after. And right above, right. 10 is for right error. And then if it's 20, well, else just to read error. Simple, stupid. Stupid simple. Oh yeah, can't find. Is it just this? Which Pico tool? Okay. Export. Don't remember where I installed it. Okay, never mind. Let's run sig build again. And what am I doing? Yeah. Okay, gotta put it in boot select. Okay. Oh, okay. That's good. Hey, I'm kind of, I don't know if you can see that. I think you can. So, that's cool. I got a debug display. Okay. So that means, so the problem is here. Can't read into the buffer. Does it say what the actual error is? Receive error. Oh, there's a few errors. Interesting. So if I understand correctly, can I print? That's one way. Can I just print an enum? Error set is like an enum, however, integer greater than 0. Let's have a look. Type the global error set type, merging, invert. Tell you what, it's not going to be pretty, but it's going to check each of them. Okay, yeah. Switch error. Yeah. If I do dot, what was the error types? I'll just copy this. Okay, and then this. Can I, yeah, I'll just return 20. I'll return 21. Return 22. 23. And 24. Else return 25. Beautiful. Don't even need that. Okay, not sure if that's like correct syntax. It's taking a bit to build. Did I break it? Okay. Expected type. Okay, so this should be just that. Yeah. Okay. Hang on. Okay. Will that work? No. Does not support field access. Okay. Gonna ask chat GPT. P3. If I have this error set, how can I? What's it called? How can I check the returned error is one of these using switch? Errors, yeah. What the fuck? That looks wrong. Doesn't even make sense. Okay, hang on. Seg check error type. Okay. This one's been pretty useful. Oh, is that another way? No exceptions. Errors are values. Let's create some error set. Okay. Okay. It's fine. What I'm gonna do is I'm gonna program caveman style. Do is if error equals receive error. It's probably like a better way. It always is. Okay, so where's where am I getting the error from? UART. Yes. No. 20. Const receive error is RP2040. It probably should be up there. Dot UART dot receive error. No? Receive, R-E-C-E. R-E-C-E-I. Okay. It's good work. This, oops, turn 20. Yeah, I'm not done. Oh, fuck it. So it's break error. Anyone? Says parity error 0 22. Oh fuck. Yeah, you're right. Okay. What are the other ones? Framing and timeout. And then otherwise return 20. One is timeout. 20, 20, 21, 22, 23, 24. Don't need these. Okay. One sec. Build. Parity. Yeah. Yes. Okay. Let's put it in boot select. Okay. Okay, let's have a look. Ah, motherfucker. I forgot to print. Oh, hang on. Oh, no. Yeah, if it's not 10. Oh, jeez. Okay, I gotta figure a way to cast int. No, U8. Is it U8? What am I returning? Yeah. To const U8 sig. Think Okay, I lost chat. Zig, how can I turn a U8 into const U8? Example 8 to 8. What the fuck? Is this like the simplest way to do it? Okay. Yeah, I can do that. Buff print. Okay. Code not equals 0. Yeah. Got a buffer. Const code string code standard dot bump dot what the fuck buff print. U8 U8 and args. Buffer nothing. When I need to sounds suspicious. And then oh yeah, okay. I see what I'm doing now. And if there's an error, just turn the LED on. Then return. Otherwise, you can print. Yeah. Actually, oh, that's the last one. That it? Const U8. Yep. I think that's it. Well, let's see what the build loads say. Okay, good. Come on. Error. $23. Yeah. Okay, we're getting somewhere. Framing error. Okay. Let me make a note of this because I will look at it tomorrow. To do. Hang on, not yet. Yeah. Currently returning framing error. To do. Fix this. Currently fails with an error or framing error that I can actually fix. Put this here. Operation mode, data, stop bits. This can be ignored. Okay. Let's save this. Made some decent progress for now. All things considering. Where did I make progress on the ESP01S? Okay. Oh. Oh. Rebase. Oh, damn. Okay. I mean, that wasn't perfect. There was a lot of scuffing, but I feel like I'm making progress. The fact that I'm able to like write stuff, just not able to read it back, which can be fixed because I did read about framing somewhere here. Yeah. So I just gotta fix this. Okay, let's go. That's good. I'm quite happy with that. I will do that tomorrow. I gotta go to the gym. All right. Thank you for watching, and I will see you tomorrow. Bye bye.